China refuses to admit there are problems with their artificial islands, but 2025 satellite analysis tells a different story entirely. Independent researchers using advanced imaging technology have documented settlement patterns and structural cracks across the 3,200 acres of reclaimed land China has built since 2013. At Fiery Cross Reef, runway subsidence has been detected at several centimeters per year, while emergency reinforcement work appears underway at multiple installations. While Chinese officials maintain these islands represent successful territorial expansion, the evidence suggests signs of serious engineering challenges that may outweigh their strategic value. To understand what's really happening, we need to examine the massive scale of what China has actually constructed in the South China Sea. The current state of China's island empire. China's artificial island construction represents one of the most ambitious engineering projects in modern history. Between 2013 and 2017, China transformed 7 coral reefs into functional military and civilian installations, creating over 3,200 acres of new land in the South China Sea. These massive construction efforts have fundamentally altered the geography of one of the world's most important waterways, turning submerged coral formations into concrete platforms that can be seen from space. Fiery Cross Reef stands as the crown jewel of this artificial archipelago. The installation now features a 3,125-meter runway capable of handling large military transport aircraft and fighter jets. Construction costs for this single facility reportedly reached around $12 billion, reflecting the enormous expense of building infrastructure hundreds of miles from the mainland. This runway stretches across nearly the entire length of the artificial island, flanked by aircraft hangars, fuel storage facilities, and what appears to be advanced radar installations. The runway surface consists of reinforced concrete designed to withstand the constant exposure to saltwater and tropical weather conditions. Subsidence Reef has been transformed into a major naval facility with deepwater port capabilities that can accommodate destroyers and possibly larger vessels. The harbor infrastructure includes concrete piers extending into artificially deepened waters, with what satellite imagery suggests are submarine berthing facilities. Large warehouse structures line the harbor area, presumably for storing supplies and equipment needed to support extended naval operations hundreds of miles from mainland China. Mischief Reef showcases China's investment in surveillance and communication technology. The installation features multiple radar towers and satellite communication arrays that provide China with enhanced monitoring capabilities across the South China Sea shipping lanes. These radar installations can track aircraft and naval vessels across a radius of several hundred miles, effectively extending China's surveillance network far beyond its natural borders. The human presence on these artificial islands has expanded dramatically over the past decade. China initially stationed about 200 soldiers across these installations in 2014, but current estimates suggest the permanent personnel count has grown substantially as facilities became operational. This personnel increase includes military operators, civilian contractors, maintenance crews, and what China describes as research scientists conducting marine and atmospheric studies. China maintains these installations serve primarily civilian purposes, describing them as research stations focused on marine biology, weather monitoring, and navigation safety. Official Chinese statements emphasize the facility's role in supporting fishing fleets and providing emergency shelter for vessels caught in storms. However, the 2016 International Tribunal ruling found that artificial islands cannot generate exclusive economic zones, undermining China's legal claims that these installations establish territorial waters. Chinese media regularly features stories about scientists on these islands conducting important research on coral reef restoration and climate change impacts. The reality visible in satellite imagery tells a different story. The infrastructure on these islands clearly serves military purposes that extend far beyond civilian research needs. The massive runway at Fiery Cross Reef exceeds the requirements for civilian research aircraft, while the deepwater facilities at Subsidence Reef appear designed for military vessels rather than fishing boats. Advanced radar installations and communication arrays suggest intelligence gathering and military coordination capabilities. Independent monitoring organizations have begun documenting unusual patterns across multiple Chinese artificial island installations. These patterns include changes in surface coloration that could indicate concrete degradation, alterations in vegetation growth that might suggest soil stability issues, and the appearance of new construction equipment that wasn't present in previous surveillance imagery. Thermal imaging has revealed temperature variations in building foundations that structural engineers find concerning. Recent satellite analysis shows construction activity that appears focused on repairs rather than expansion. Previously completed structures are being reinforced with additional concrete and steel supports, while new seawalls are being constructed around existing installations. This remedial construction suggests China may be addressing problems that weren't anticipated during the original construction phase. The timing of these observations makes 2025 a critical year for assessing the long-term viability of China's artificial island strategy. The installations have now been operational long enough for structural issues related to foundation settlement and environmental degradation to become apparent. Engineering experts note that artificial islands typically experience their most significant structural challenges between 5 and 10 years after initial construction, as underlying sediments consolidate and environmental stresses accumulate. Construction costs for these islands have reportedly exceeded initial estimates by substantial margins, with maintenance requirements proving more extensive than originally planned. The remote location of these installations makes routine maintenance complex and expensive, requiring specialized equipment and materials to be transported hundreds of miles by sea or air. Emergency repairs become exponentially more costly when problems develop in structures that cannot be easily accessed by conventional construction crews. The strategic value of these installations depends heavily on their structural integrity and operational reliability. Military aircraft require runways that meet strict safety standards, while naval vessels need harbors with consistent depth and structural stability. Any compromise in the reliability of these facilities reduces their military utility and potentially creates operational hazards for personnel and equipment. Weather patterns in the South China Sea create additional challenges for maintaining artificial structures. The region experiences regular typhoons that generate massive waves and sustained winds capable of causing significant structural damage. Rising sea levels and increasing storm intensity associated with climate change may create conditions that exceed the design parameters of these artificial installations. The coral reef foundations underlying these artificial islands present unique engineering challenges not encountered in other land reclamation projects. Unlike projects built on stable seabeds or existing landmasses, these installations rest on compressed coral fragments and sediment that continues to settle and shift over time. This ongoing geological instability requires constant monitoring and potentially expensive remedial work to maintain structural integrity. International observers have noted that structural problems with China's artificial islands could have implications extending beyond engineering concerns. The viability of China's territorial claims in the South China Sea may depend partly on demonstrating effective control over these installations. Islands that require constant expensive repairs or become operationally unreliable could undermine China's arguments for permanent territorial control. The full extent of these challenges has only recently become visible to outside observers through advanced monitoring technology that can detect changes invisible to conventional surveillance methods. What 2025 satellite analysis actually shows? Modern satellite technology can now track structural changes with remarkable precision. MODIS backscatter analysis detected 62 square kilometer sediment plumes from China's dredging operations, demonstrating how advanced monitoring systems can document even underwater construction activity. Synthetic aperture radar and high-resolution optical imaging detect changes as small as a few millimeters in concrete surfaces and building foundations, operating independently of weather conditions and cloud cover that previously blocked assessment of these remote installations. Independent monitoring organizations use multiple satellite platforms to create comprehensive assessments of artificial island conditions. Synthetic aperture radar measures surface displacement by comparing images taken weeks or months apart, revealing structural settlement invisible to casual observation. Computer analysis processes thousands of measurement points across each artificial island, creating detailed maps of surface movement and structural change over time. Fiery Cross Reef shows the most concerning evidence of structural problems documented across China's artificial island network. Multiple sections of the main runway display measurable subsidence, with natural sediment consolidation causing several centimeters of annual sinking in areas where the runway crosses originally deeper sections of the coral reef. The massive weight of concrete runway structures appears to exceed the load-bearing capacity of the underlying compressed coral and sediment, creating uneven foundation settlement that poses operational hazards for aircraft operations. The runway subsidence creates dangerous conditions during takeoff and landing, particularly for heavy military transport aircraft requiring precise runway conditions. Satellite measurements show the subsidence is not uniform across the runway length, creating surface irregularities that compromise aircraft safety. The ongoing settlement suggests this problem will worsen over time unless expensive remedial construction addresses the underlying foundation issues. Concrete cracking patterns have become visible across multiple Chinese artificial island installations during 2025. Harbor infrastructure shows particularly extensive cracking, with linear fractures extending across pier surfaces and harbor walls exposed to constant wave action and tidal stress. Subsidence Reef displays extensive cracking in its deepwater port facilities, where concrete piers show multiple fracture lines visible from satellite altitude. These fractures create pathways for saltwater intrusion that accelerate concrete degradation and steel reinforcement corrosion. Satellite images from April 2024 show new concrete buttresses at Fiery Cross Reef that were not part of original construction plans. These reinforcements extend deep into artificial island foundations, suggesting attempts to transfer structural loads to more stable underlying materials. Foundation strengthening work has become apparent around existing building foundations, requiring substantial new construction equipment and materials not previously present on the installations. New seawall construction has begun at several installations, with concrete barriers being built seaward of existing structures showing signs of stress and damage. Color anomalies in high-resolution imagery suggest possible material changes across artificial island structures. Building foundations show variations that correlate with areas where other monitoring techniques have detected structural problems. These visual indicators appear most pronounced in concrete structures exposed to constant marine conditions, providing additional evidence of material degradation processes. Multiple indicators point to systematic structural stress rather than routine maintenance activities. Temporary construction equipment, including concrete mixing plants, construction cranes, and material storage areas, now occupy spaces that were previously clear across multiple artificial islands. Construction materials, including steel reinforcing bars and specialized marine construction equipment, have been transported in quantities suggesting major repair projects. Vegetation patterns have changed in ways that indicate soil stability problems, with areas near building foundations showing plant stress that correlates with locations where satellite measurements have detected surface settlement. Expert analysis indicates these observed changes represent systematic structural problems rather than routine maintenance activities. The geographic distribution of problems across multiple installations suggests common underlying issues related to artificial island construction methods and environmental conditions. Structural engineers reviewing satellite evidence note that the types and extent of problems visible from space indicate fundamental challenges with building permanent structures on coral reef foundations. The timing and scale of structural problems becoming visible in 2025 aligns with engineering predictions about artificial island settlement and degradation patterns. Structures built on compressed sediment and coral typically experience their most significant settlement between 5 and 10 years after construction. The correlation between predicted and observed structural problems suggests these artificial islands may be experiencing engineered failure modes that require increasingly expensive solutions. Multiple independent monitoring organizations have reached similar conclusions about the systematic nature of structural problems across China's artificial island network. The consistency of observations across different monitoring systems and analysis methodologies strengthens confidence that documented problems represent real structural challenges rather than measurement errors. The evidence suggests China faces more widespread and serious engineering challenges than officials have publicly acknowledged. The scale and nature of these documented problems reveal that China may have underestimated the fundamental engineering obstacles involved in this unprecedented construction project. What satellite analysis shows is not simply maintenance issues or minor settling, but evidence of systematic challenges that go to the heart of whether permanent structures can be successfully maintained on coral reef foundations in one of the world's most challenging marine environments. The engineering nightmare behind artificial islands. These technical challenges reveal why building on coral reef foundations creates engineering problems unlike any other construction environment. Coral reefs consist of fragmented calcium carbonate structures that provide minimal load-bearing capacity for heavy concrete and steel installations. The reef material compresses and shifts under weight, creating unstable foundations that cannot support large buildings or runways without extensive preparation. Traditional foundation techniques developed for solid bedrock or stable soil conditions prove inadequate when applied to the fragmented coral substrate found throughout the South China Sea. Creating artificial islands begins with dredging millions of tons of sediment from surrounding seabeds and depositing this material over coral reef areas. At Mischief Reef, coral was buried under millions of tons of sand, causing extensive ecosystem damage documented in AMTI research. This dredged material consists primarily of sand, coral fragments, and fine sediments that must undergo natural consolidation before they can support permanent structures. The consolidation process involves the gradual compression of sediment particles as water is squeezed out and material settles under its own weight. This consolidation continues for several decades after initial construction, causing ongoing settlement that affects any structures built on top of the artificial land. Sediment consolidation rates vary depending on the composition and depth of dredged material, but artificial islands typically experience several centimeters of settlement annually during their first decade of existence. The settlement occurs unevenly across different areas of each artificial island, depending on the depth of dredged material and the underlying reef structure. Areas where deeper dredging was required to create land experience more settlement than areas built over shallower reef sections. This uneven settlement creates differential stress in buildings and runways that can lead to structural cracking and foundation problems. The South China Sea presents geological conditions that create engineering challenges not encountered in other artificial island projects worldwide. The region sits on an active tectonic zone where multiple geological plates interact, creating seismic activity that adds stress to artificial structures. Ocean currents in the South China Sea are stronger and more variable than in many other locations where artificial islands have been constructed successfully. The combination of seismic activity, strong currents, and deep water creates an environment where artificial islands face constant geological and hydrodynamic stresses. Subsidence affects every artificial island built on coral reef foundations, with rates that can exceed several centimeters per year even after initial construction is complete. The subsidence occurs because coral reef materials continue to compress under the weight of overlying structures and sediment. Unlike natural islands formed through geological processes over millions of years, artificial islands lack the structural integrity that comes from consolidated bedrock foundations. The ongoing subsidence creates maintenance requirements that persist throughout the operational life of artificial installations. Saltwater exposure accelerates the deterioration of concrete and steel infrastructure beyond rates anticipated during initial construction planning. Research on marine concrete shows that steel reinforcement corrosion occurs at accelerated rates due to saltwater exposure, with chloride ions penetrating concrete and attacking steel reinforcement bars. The warm tropical waters of the South China Sea increase the rate of chemical reactions that cause material degradation. Concrete structures in this environment experience corrosion rates that can be 3 to 5 times higher than similar structures in temperate freshwater environments. The concrete mix designs used in artificial island construction must account for saltwater exposure, but even specialized marine concrete experiences accelerated deterioration in the harsh South China Sea environment. Protective coatings and corrosion inhibitors help slow the degradation process, but they require regular maintenance and replacement to remain effective. The constant exposure to saltwater spray and tidal action means that concrete surfaces never completely dry, creating conditions where chemical degradation continues around the clock. Typhoons present recurring challenges for artificial island infrastructure that natural islands can better withstand through geological stability and natural wave-breaking features. Engineers warn that a single Category 4 typhoon could wash parts of low-lying artificial runways back into the sea. The flat, engineered surfaces of artificial islands provide little protection against wind and wave forces during major storms. Typhoon winds can exceed 150 miles per hour, creating wave heights that overtop artificial island shorelines and flood inland structures. Wave action and tidal forces create constant mechanical stress on artificial island foundations and shoreline structures. The South China Sea experiences tidal ranges that can exceed 3 meters, subjecting artificial island foundations to regular cycles of hydrostatic pressure changes. Wave action during normal weather conditions generates ongoing vibration and impact forces that gradually weaken concrete structures and foundation materials. The cumulative effect of millions of wave impacts over years creates fatigue damage that can lead to structural failure even when individual wave forces remain within design limits. Traditional engineering solutions become exponentially more expensive when applied 500 miles from mainland support infrastructure. Specialized construction materials, equipment, and personnel must be transported by ship or aircraft to remote artificial island locations. The transportation costs for heavy construction materials can exceed the material costs themselves when delivery requires specialized vessels and extended ocean voyages. Emergency repairs cost even more because they often require immediate mobilization of equipment and personnel regardless of weather conditions or availability. Weather conditions in the South China Sea limit the number of days each year when construction and maintenance work can be performed safely. High winds, rough seas, and tropical storms create extended periods when personnel cannot work outdoors or when supply ships cannot approach artificial island facilities. These weather delays increase project costs and create scheduling challenges that compound throughout extended construction and maintenance operations. These engineering challenges may have been underestimated during initial planning phases when China committed to artificial island construction in the South China Sea. The combination of unstable foundations, aggressive environmental conditions, and remote location creates engineering problems that exceed those encountered in most other construction projects worldwide. What makes these challenges even more daunting is that they represent only the human-made obstacles China faces in maintaining these installations. Environmental forces fighting back. The South China Sea operates as a natural system that actively resists human attempts to impose permanent artificial structures on its waters. Ocean currents, tidal forces, and seasonal weather patterns have shaped this marine environment for millions of years, creating conditions that favor flexible, adaptive ecosystems over rigid concrete installations. The sea's natural processes continue regardless of human construction activities, creating ongoing pressure against artificial islands that must constantly resist forces designed to break down and redistribute sediment and organic matter. Sea level rise has accelerated throughout the South China Sea region, with current rise rates of 1.836 per year as of 2025. This acceleration creates conditions that artificial island designers did not anticipate during initial construction planning. The rapid rise means that structures built at specific elevations above sea level in 2015 now face regular flooding during high tides and storm surges. Artificial islands built with minimal elevation above mean sea level find their operational areas shrinking as rising waters claim land that was previously dry and usable. The low-lying nature of artificial islands makes them particularly vulnerable to rising sea levels compared to natural land masses that typically feature varied topography and higher elevations. Artificial islands were constructed with relatively flat surfaces to maximize usable land area and simplify construction operations. This design choice means that small increases in sea level affect large portions of each installation simultaneously. Natural erosion and subsidence could make some islands sink within decades, creating conditions where areas that previously remained dry, except during major storms, now experience regular saltwater flooding that damages equipment, buildings, and infrastructure. Intensified typhoon activity across the South China Sea basin creates storm conditions that exceed the design parameters established for artificial island construction. Modern typhoons generate sustained winds above 150 miles per hour and create wave heights that can exceed 15 meters during peak storm conditions. These extreme weather events have become more frequent and more powerful than historical patterns suggested when artificial island construction began. The increased intensity means that storms now regularly produce conditions that artificial island infrastructure was not designed to withstand. Typhoon damage extends beyond immediate storm impacts to include long-term structural weakening from repeated exposure to extreme conditions. Each major storm subjects artificial island structures to stress loads that approach or exceed design limits, creating cumulative damage that reduces structural integrity over time. Buildings and infrastructure that survive individual storms accumulate fatigue damage that makes them progressively more vulnerable to future weather events. The increasing frequency of intense storms means that structures experience damaging conditions more often than anticipated during design phases. Coastal erosion affects artificial islands differently than natural land masses because they lack the geological stability and natural defenses that help genuine islands resist wave action and tidal forces. Natural islands typically feature consolidated bedrock foundations and irregular shoreline features that dissipate wave energy effectively. Artificial islands consist of loose sediment and coral fragments held in place by engineered structures that provide less effective protection against erosive forces. The uniform, engineered shorelines of artificial islands concentrate wave energy rather than dissipating it across natural features. The construction materials used to create artificial island foundations remain susceptible to erosion throughout their operational lifetime. Dredged sediment used to build artificial land continues to compact and shift under wave action and tidal forces. Unlike natural islands that benefit from ongoing sediment deposition and geological consolidation processes, artificial islands must rely entirely on engineered solutions to maintain their size and shape. The ongoing erosion means that artificial islands require constant maintenance and periodic reconstruction to replace land lost to natural processes. Ocean current patterns throughout the South China Sea have shifted in response to artificial island construction, creating feedback effects that accelerate erosion and foundation instability. Large artificial structures alter natural water flow patterns, potentially creating areas of increased current velocity that cause accelerated erosion around island foundations. Changes in sediment transport patterns mean that artificial islands may not receive natural sediment replenishment that could help offset erosional losses. The altered currents can also create new areas of sediment deposition that change water depths and navigation conditions around artificial installations. The environmental destruction caused by artificial island construction has eliminated natural defenses that previously protected these reef areas. At least 8,572 hectares of reef have been destroyed by dredging and giant clam harvesting, removing coral formations that naturally dissipated wave energy and provided habitat for marine organisms. The destruction of coral reefs eliminates natural breakwaters that help protect shallow areas from wave action and storm surge. Without these natural defenses, artificial islands face the full force of ocean conditions that were previously moderated by living reef systems. Marine-boring organisms present a persistent biological threat to concrete structures in tropical waters that cannot be eliminated through engineering solutions. These organisms, including various species of shipworms and other marine borers, evolved to break down organic material in marine environments and attack concrete structures that contain organic components or provide suitable habitat. The warm waters of the South China Sea provide ideal conditions for rapid reproduction and growth of boring organisms that can penetrate concrete and weaken structural foundations. Temperature fluctuations in the South China Sea create daily and seasonal cycles of thermal expansion and contraction that gradually weaken artificial structures through repeated stress. Concrete and steel materials expand when heated by tropical sunlight and contract during cooler nighttime temperatures. These expansion cycles create stress at joints, connections, and interfaces between different materials. The cumulative effect of thousands of expansion cycles over years can cause crack formation and structural weakening, even when individual temperature changes remain within normal ranges. Multiple environmental stressors work simultaneously against artificial island infrastructure, creating cumulative damage that exceeds the sum of individual effects. Rising sea levels combine with increased storm intensity to create flooding conditions that exceed design parameters. Thermal expansion cycles occur while structures simultaneously resist wave action and settle on unstable foundations. The interaction between multiple degradation processes creates conditions where artificial islands face environmental challenges that require increasingly expensive solutions to overcome. The scale of these mounting environmental pressures raises fundamental questions about the long-term economic viability of maintaining these installations. The staggering financial reality. Construction costs alone reveal the extraordinary financial commitment China has made to this unprecedented project. By 2025, individual installations like Fiery Cross Reef have cost an estimated $12 billion, representing one of the most expensive military construction projects ever undertaken in a marine environment. This massive investment transforms submerged coral reefs into functional military and civilian facilities featuring runways, harbors, radar installations, and permanent housing for military personnel. The scale of spending reflects China's determination to establish permanent territorial control over disputed waters, regardless of the enormous costs involved in building and maintaining structures hundreds of miles from mainland support infrastructure. The breakdown of these construction costs reveals the complexity and expense of creating artificial land in one of the world's most challenging marine environments. Initial dredging operations required specialized vessels capable of moving millions of tons of sediment from seabeds to reef locations. Heavy construction equipment had to be transported by ship to remote locations where no existing infrastructure existed to support major building projects. Concrete production facilities were established on site to avoid the cost and logistical challenges of transporting massive quantities of building materials across hundreds of miles of open ocean. Ongoing maintenance expenses continue to escalate as structural problems compound across multiple installations. These expenses include routine upkeep of runways, harbors, buildings, and support infrastructure that deteriorates rapidly in the harsh tropical marine environment. The maintenance costs also cover personnel salaries, supply shipments, equipment replacement, and the specialized marine construction work needed to address foundation settlement and concrete degradation issues that affect every artificial island. AMTI and RAND projects suggest that defending each outpost would require 30 to 50 cruise missiles, implying substantial recurring costs for maintaining adequate defensive capabilities at these remote installations. The maintenance cost escalation becomes more dramatic when compared to initial projections that assumed expenses would decrease over time as construction projects reached completion. Instead, maintenance requirements have proven more extensive and expensive than planners anticipated during the initial construction phase. The remote location means that simple repairs require extensive logistical preparation and specialized equipment that must be transported from mainland China or other regional facilities. China has responded to mounting maintenance demands by investing in increasingly powerful equipment. The world's largest suction dredger deployed for artificial island maintenance is 50% more powerful than the previous generation, illustrating the scale of resources China continues to commit to addressing ongoing structural challenges. This equipment investment demonstrates that maintenance requirements have exceeded original projections and continue to demand increasingly sophisticated solutions. Specific repair projects illustrate the extraordinary costs associated with maintaining artificial island infrastructure. The runway reconstruction project at Fiery Cross Reef, completed in 2024, cost an estimated $800 million, representing one of the most expensive single infrastructure projects ever undertaken on an artificial island. This reconstruction became necessary because foundation settlement and concrete deterioration compromised the runway's structural integrity and operational safety. The project required complete removal and replacement of damaged runway sections, along with foundation reinforcement work designed to prevent future settlement problems. The Fiery Cross runway reconstruction involved importing specialized marine concrete designed to resist saltwater intrusion and thermal expansion cycles in tropical conditions. Heavy construction equipment, including concrete mixers, paving machines, and foundation drilling rigs, had to be transported to the remote installation by specialized vessels. The project timeline extended beyond initial estimates because weather conditions in the South China Sea limited the number of working days when construction activities could proceed safely. Maintenance costs have increased by 340% since 2020 as structural problems compound and require increasingly expensive solutions. This dramatic cost escalation reflects the cumulative effect of foundation settlement, concrete deterioration, and environmental damage that affects every aspect of artificial island infrastructure. Buildings require more frequent repairs as saltwater intrusion accelerates steel corrosion and concrete cracking. Runways need regular resurfacing and foundation work to address ongoing settlement issues. Harbor facilities require constant maintenance to address wave damage and foundation instability. The compounding nature of structural problems means that maintenance costs continue to accelerate rather than stabilizing at predictable levels. Foundation settlement creates stress concentrations that cause new cracks and structural damage requiring additional repairs. Saltwater intrusion through existing cracks accelerates material degradation and creates new areas of structural weakness. The interaction between multiple degradation processes creates maintenance requirements that exceed the sum of individual problems. Logistical expenses represent a major component of artificial island operating costs that continue throughout the operational lifetime of each installation. Regular supply shipments must transport food, fuel, construction materials, and equipment to locations hundreds of miles from mainland ports. Personnel rotation requires scheduled flights or ship transportation that operates regardless of weather conditions or operational requirements. Emergency supply runs cost significantly more than routine shipments because they often require immediate mobilization of transportation assets. Emergency repairs cost exponentially more than planned maintenance because they require immediate mobilization of personnel and equipment, regardless of availability or weather conditions. Storm damage often occurs during periods when regular supply ships cannot safely approach artificial island facilities, requiring expensive emergency transportation by military vessels or aircraft. Emergency construction materials must be sourced quickly, without the cost savings available through bulk purchasing and advanced planning. Analysis of current spending trends suggests total lifetime costs for China's artificial island network could exceed $100 billion if maintenance requirements continue escalating at current rates. This projection accounts for ongoing structural degradation that will require increasingly expensive repairs and eventual reconstruction of major infrastructure components. The calculation includes personnel costs, supply chain expenses, and capital equipment replacement over a projected operational lifetime of 30 to 50 years. Alternative military strategies could potentially achieve similar strategic objectives at substantially lower costs than maintaining artificial island installations. Mobile naval assets including aircraft carriers, destroyers, and submarine facilities provide flexible military capabilities without the vulnerability and maintenance requirements of fixed installations. Advanced surveillance satellites and underwater sensor networks could provide intelligence-gathering capabilities without requiring permanent personnel stationed on remote artificial platforms. These mounting financial pressures raise critical questions about whether the strategic benefits these installations were designed to provide justify their extraordinary costs and ongoing operational challenges. Military value versus strategic liability. China's artificial island strategy was designed to deliver three primary strategic advantages that would fundamentally alter the balance of power in the South China Sea. Extended radar coverage would allow Chinese forces to monitor aircraft and naval movements across shipping lanes that carry over $3 trillion in annual trade. Forward air bases positioned hundreds of miles from mainland China would project military power deep into disputed waters while reducing response times to regional incidents. Most importantly, these installations would strengthen China's territorial claims by demonstrating effective administrative control over areas that multiple nations dispute. The military infrastructure present on these artificial islands represents a substantial investment in forward-deployed capabilities. As of 2025, major installations can accommodate up to 24 fighters per island, along with supporting infrastructure including fuel storage, maintenance hangars, and weapons storage areas. Advanced missile defense systems protect each installation, while radar installations provide surveillance coverage extending several hundred miles in all directions. Deepwater harbors accommodate destroyers and support vessels, creating logistics hubs that can sustain extended military operations far from mainland ports. Fiery Cross Reef operates as the primary air operations center with its 10,000-foot runway capable of supporting heavy military transport aircraft, fighter jets, and potentially strategic bombers. The runway includes taxiways, aircraft parking areas, and underground hangar facilities that protect valuable aircraft from weather and potential attacks. Reef functions as the main naval facility with harbor infrastructure designed to support multiple surface vessels simultaneously. Mischief Reef serves as the primary intelligence gathering center with multiple radar towers and communication arrays that coordinate surveillance across the entire artificial island network. The current military capabilities appear impressive on paper, but structural problems directly undermine the operational effectiveness of these installations. Runway subsidence at Fiery Cross Reef creates safety hazards that limit the types of aircraft operations that can be conducted safely. Military transport aircraft require precise runway conditions to operate safely with heavy loads, and even minor surface irregularities can cause dangerous situations during takeoff and landing operations. Fighter aircraft operations become particularly risky when runway surfaces experience uneven settlement that creates unexpected bumps or depressions. Harbor deterioration at Reef limits the size and type of naval vessels that can use the facility safely. Concrete cracking in pier structures reduces the weight-bearing capacity for moored vessels, while foundation settlement affects the precision required for submarine operations. Deepwater naval operations require stable harbor facilities with consistent depths and reliable structural integrity. Damaged harbor infrastructure creates operational restrictions that reduce the military utility of these installations below their designed capabilities. The concentration of military assets on fixed, isolated platforms creates vulnerabilities that mobile forces do not face. These artificial islands function essentially as stationary aircraft carriers that cannot relocate when threatened, making them attractive targets for missile attacks or other forms of assault. Unlike actual aircraft carriers that can change position and avoid concentrated enemy fire, artificial island air bases remain stationary and predictable. Enemy forces can plan attacks knowing exactly where aircraft and support equipment will be located, reducing the defensive advantages typically provided by mobility and unpredictability. Naval vessels using artificial island harbors face similar vulnerability issues when moored to fixed installations. Ships in harbors cannot maneuver effectively to avoid incoming threats, and harbor infrastructure provides enemy forces with predictable target locations. The concentration of multiple valuable military assets in small geographic areas creates opportunities for enemies to inflict maximum damage with single attacks. Traditional military doctrine emphasizes dispersal of assets to reduce vulnerability, but artificial islands require concentration of forces in defensible positions. Maintenance requirements consume military resources that could otherwise be deployed for operational missions. Personnel assigned to artificial island maintenance duties cannot simultaneously perform combat operations or training exercises. Construction crews, supply ship operators, and facility maintenance workers represent military assets tied to infrastructure support rather than tactical operations. The specialized nature of artificial island maintenance means that personnel cannot easily transfer between maintenance duties and combat roles when operational requirements change. Military equipment dedicated to artificial island maintenance becomes unavailable for other strategic purposes. Heavy construction equipment, specialized transport vessels, and marine engineering assets remain committed to ongoing repair projects rather than supporting mobile military operations. The unpredictable nature of structural problems means that maintenance requirements can suddenly increase, pulling additional resources away from planned military activities. Emergency repairs often require immediate deployment of scarce specialized equipment, regardless of other operational priorities. Expert military analysts increasingly question whether mobile assets might provide superior strategic value compared to fixed artificial island installations. Aircraft carrier battle groups offer similar forward air capability while maintaining the flexibility to relocate based on tactical requirements. A single carrier strike group can project power across vast ocean areas without requiring vulnerable surface installations that enemy forces can target easily. The mobility advantage becomes particularly significant when considering that U.S. forces could potentially neutralize artificial islands with submarine or cruise missile strikes, requiring only 30 to 50 missiles per outpost to disable major infrastructure. Structural unreliability creates operational risks that extend beyond maintenance costs to affect mission capability and personnel safety. Military operations require predictable infrastructure performance, and structural problems introduce uncertainty that can compromise mission planning and execution. Personnel assigned to artificial islands face risks from failing infrastructure that could cause injuries or equipment damage during routine operations. Combat operations become particularly dangerous when conducted from installations with questionable structural integrity. Equipment damage from structural failures creates additional operational costs and capability gaps. Expensive military aircraft and naval vessels can suffer damage from runway settlement or harbor deterioration that affects their operational readiness. Radar installations and communication equipment require stable foundations to operate effectively, and structural movement can degrade their performance or cause complete system failures. The cost of replacing damaged military equipment often exceeds the cost of infrastructure repairs that could have prevented the damage. The assessment of whether these installations enhance or compromise China's military position depends largely on their operational reliability and strategic vulnerability. Fixed installations that require extensive maintenance while remaining vulnerable to enemy attack may represent strategic liabilities rather than assets. The substantial resources committed to artificial island construction and maintenance might have provided greater strategic value if invested in mobile capabilities that offer similar military functionality without the associated vulnerabilities and ongoing costs. These mounting strategic concerns have not gone unnoticed by regional governments, who are beginning to reassess their own security arrangements in response to what they perceive as both Chinese expansion and the apparent limitations of Beijing's artificial island strategy. Regional responses and diplomatic consequences. The Philippines has taken the most decisive action among regional nations, expanding joint military exercises with the United States in 2025, while explicitly citing concerns about unstable Chinese installations as justification for increased military cooperation. Manila's decision represents a significant escalation from previous diplomatic protests to active military preparation for potential scenarios involving Chinese artificial island operations. The expanded exercises include training scenarios focused on maritime security operations in disputed waters, with particular emphasis on responding to incidents involving structurally compromised installations that could pose navigation hazards or environmental threats. Philippine military officials have expressed concerns that structural failures on Chinese artificial islands could create maritime safety hazards that affect international shipping lanes and fishing operations. The possibility of runway debris, concrete fragments, or other structural materials entering shipping channels poses risks to commercial vessels that transit these heavily traveled waters. Philippine Coast Guard units have increased their monitoring activities in areas adjacent to Chinese artificial islands, documenting changes in water conditions and debris patterns that could indicate ongoing structural deterioration. The expanded joint exercises between the Philippines and United States now include specialized training for responding to maritime emergencies that could result from artificial island structural failures. These scenarios involve coordinated search and rescue operations, environmental containment procedures, and navigation safety protocols designed to address potential hazards created by failing infrastructure. The training programs reflect growing regional concerns that Chinese artificial islands represent not only territorial disputes, but also potential sources of maritime safety risks. Vietnam has significantly increased Coast Guard patrols and surveillance activities targeting Chinese artificial island operations, with particular focus on monitoring construction activities and structural conditions. Vietnamese patrol vessels now conduct regular reconnaissance missions that document ongoing repair work, construction equipment deployments, and changes in artificial island configurations. These patrols operate under the guise of routine maritime security operations, while gathering intelligence about the true condition of Chinese installations. Vietnamese Coast Guard units have reported unusual patterns of Chinese construction vessel activity that suggest extensive repair operations rather than routine maintenance. The frequency and scale of repair work observed by Vietnamese patrols indicate that Chinese artificial islands require more intensive maintenance than originally anticipated. Vietnamese officials have used this intelligence to support their position that Chinese territorial claims, based on artificial island construction, lack the permanence and stability required for legitimate territorial control. The increased Vietnamese surveillance operations have documented specific instances of emergency repairs, including the rapid deployment of construction equipment following storm damage and the apparent reinforcement of existing structures showing signs of structural stress. Vietnamese intelligence assessments suggest that Chinese artificial islands face ongoing engineering challenges that compromise their military utility and territorial claim value. This intelligence has strengthened Vietnam's diplomatic position in international forums where South China Sea territorial disputes are discussed. Other ASEAN neighbors, including Malaysia and Indonesia, have increased patrols and joint drills in response to regional tensions created by Chinese artificial island activities and their apparent structural problems. These nations have established new protocols for responding to maritime incidents that could result from Chinese artificial island structural failures, including procedures for coordinating with international shipping organizations and environmental response agencies in scenarios where failing artificial island infrastructure creates navigation hazards. The Philippines is considering pursuing a second arbitration case against China, focused specifically on environmental charges related to coral reef destruction and ongoing ecological damage from artificial island construction activities. This potential legal challenge would build upon the 2016 Permanent Court of Arbitration ruling that found China's territorial claims lacked legal basis under international maritime law. Legal experts argue that installations requiring constant expensive repairs and showing signs of structural failure cannot serve as the basis for legitimate territorial claims, providing additional ammunition for countries challenging Chinese territorial positions. Evidence of artificial island structural problems has provided neighboring countries with concrete documentation that China's massive construction projects face serious engineering challenges that undermine Beijing's arguments about permanent territorial control. The visible signs of foundation settlement, concrete cracking, and emergency repair work documented through satellite imagery have emboldened regional governments to take more assertive positions against Chinese territorial claims, while strengthening military and diplomatic cooperation with allies who share similar concerns. Regional trade route planning has been affected by concerns about Chinese artificial island structural reliability, with shipping companies developing alternative routes that minimize exposure to potential hazards from failing infrastructure. Commercial shipping organizations have established new protocols for vessels transiting areas near Chinese artificial islands, including requirements for enhanced lookout procedures and emergency response preparations. These shipping industry responses reflect broader concerns about the safety implications of structurally compromised artificial installations. Fishing communities throughout the South China Sea have reported changes in fishing conditions near Chinese artificial islands that may be related to structural problems and ongoing repair activities. Traditional fishing grounds have been affected by construction debris, altered water conditions, and restricted access areas surrounding Chinese installations. The cumulative impact on regional fishing communities has created additional diplomatic complications as governments address economic losses suffered by their fishing industries. Diplomatic efforts to establish new maritime safety protocols for the South China Sea have accelerated as regional governments recognize that Chinese artificial island structural problems create shared risks requiring coordinated responses. These diplomatic initiatives focus on developing international standards for artificial island construction, maintenance requirements, and safety monitoring that would apply to all countries engaged in land reclamation activities. The mounting evidence of structural vulnerabilities across China's artificial island network has fundamentally altered regional security calculations, with neighboring countries now viewing these installations as potential liabilities rather than permanent strategic assets. This shift in perception has created new opportunities for countries seeking to challenge Chinese territorial expansion, while raising questions about how major powers might respond to clear evidence of Beijing's engineering difficulties. The U.S. strategic response. U.S. military intelligence agencies have fundamentally restructured their South China Sea strategy after analyzing extensive satellite data revealing structural vulnerabilities across China's artificial island network. Pentagon assessments now recognize that Chinese installations face engineering challenges that directly impact their military effectiveness and operational reliability. This intelligence has prompted American strategic planners to recalibrate their approach to regional security, shifting from defensive positioning to more assertive operations that capitalize on Chinese infrastructure weaknesses. The transformation in U.S. strategy becomes most apparent through the dramatic expansion of freedom of navigation operations throughout disputed South China Sea waters. American naval forces have conducted operations with increased frequency during 2025, representing a substantial escalation from previous years. These operations now specifically target areas adjacent to Chinese artificial islands, where structural problems have been documented through satellite surveillance. U.S. Navy vessels deliberately transit waters near installations showing signs of foundation settlement and concrete deterioration, demonstrating American awareness of Chinese infrastructure vulnerabilities while asserting navigation rights in international waters. The increased frequency of freedom of navigation operations reflects a calculated strategy designed to test Chinese responses while gathering additional intelligence about artificial island conditions. U.S. naval commanders received detailed briefings about structural problems on specific Chinese installations before conducting operations in those areas. This intelligence allows American forces to assess Chinese military readiness and response capabilities, while potentially exploiting operational limitations created by infrastructure problems. American military partnerships with regional allies have evolved to focus specifically on monitoring and responding to Chinese artificial island activities. The Pentagon has established specialized intelligence sharing agreements with the Philippines, Vietnam, and other regional partners that provide coordinated surveillance of Chinese construction and repair activities. These partnerships combine American satellite capabilities with regional maritime patrol assets to create comprehensive monitoring networks that track changes in Chinese artificial island conditions. The Philippines serves as the primary hub for U.S. regional intelligence operations targeting Chinese artificial islands. American military advisors work directly with Philippine Coast Guard and naval units to coordinate surveillance missions that document ongoing repair work and structural problems across Chinese installations. Joint training exercises now include scenarios specifically designed to respond to maritime emergencies that could result from Chinese artificial island structural failures. The U.S. military is planning to construct the world's largest prepositioned equipment depot near Subic Bay Naval Base, marking the most significant American military logistics initiative in the Philippines since 1992. Pentagon assessments reference the March 2025 Pentagon report noting Chinese missile deployments, which provide detailed evaluations of Chinese artificial island capabilities and operational limitations based on structural condition analysis. These classified reports conclude that ongoing foundation settlement and concrete deterioration significantly reduce the military utility of Chinese installations below their designed capacity. Runway subsidence at Fiery Cross Reef limits the types of aircraft operations that can be conducted safely, while harbor deterioration at Subsidence Reef restricts naval vessel access and operations. The Pentagon analysis identifies specific operational vulnerabilities created by structural problems that American forces could potentially exploit during crisis scenarios. Damaged runway surfaces reduce Chinese aircraft sortie rates and operational flexibility. Compromised harbor facilities limit Chinese naval vessel deployment and logistics support capabilities. Ongoing maintenance requirements tie up Chinese military resources that would otherwise be available for operational missions. American surveillance technology has advanced to detect structural problems on Chinese artificial islands from significantly greater distances than previously possible. Intelligence agencies now employ Sentinel-2 and optical SAR fusion techniques for comprehensive island monitoring, providing detailed measurements of structural movement that reveal engineering problems before they become visible through conventional optical imaging. Advanced synthetic aperture radar provides continuous monitoring capabilities that allow American intelligence agencies to track Chinese artificial island conditions without relying on close-approach reconnaissance missions that could provoke diplomatic incidents. Knowledge of Chinese artificial island vulnerabilities has directly influenced U.S. military resource allocation and strategic planning throughout the South China Sea region. American forces now position mobile assets to take advantage of Chinese infrastructure limitations, while avoiding areas where Chinese capabilities remain fully operational. Naval deployments account for Chinese artificial island maintenance schedules that temporarily reduce their defensive capabilities during repair operations. The U.S. is expediting deployment of advanced weapons systems in the Philippines, including the Typhoon mid-range missile system and the NMESIS anti-ship missile system, establishing a three-tiered firepower network capable of covering the South China Sea. U.S. military planners have modified their operational doctrines to exploit the static nature of Chinese artificial islands compared to mobile American assets. Aircraft carrier battle groups provide flexible response capabilities that can avoid areas of Chinese strength while exploiting infrastructure vulnerabilities. Submarine operations focus on areas where Chinese surveillance capabilities may be degraded by structural problems affecting radar installations and communication systems. American diplomatic initiatives have emerged to establish international oversight mechanisms for artificial island construction activities throughout global maritime environments. These proposals emphasize safety standards and environmental protection requirements that would apply to all nations engaged in land reclamation projects. The diplomatic strategy aims to create international legal frameworks that could restrict or regulate future Chinese artificial island construction, while addressing legitimate concerns about maritime safety and environmental protection. Economic measures targeting Chinese companies involved in artificial island construction and maintenance represent another component of the U.S. strategic response. Sanctions imposed on specific Chinese entities limit their access to advanced construction equipment and materials needed for ongoing repair work. These economic restrictions increase the costs and complexity of maintaining Chinese artificial islands, while demonstrating American commitment to challenging Chinese territorial expansion activities. Structural problems on Chinese artificial islands have fundamentally altered regional balance of power calculations that previously assumed these installations provided China with permanent strategic advantages. American strategic assessments now recognize that Chinese artificial islands represent expensive liabilities rather than effective military assets. The ongoing maintenance requirements and operational limitations created by structural problems reduce Chinese military flexibility while tying up resources that could be deployed more effectively elsewhere. The mounting pressure from American military, diplomatic, and economic initiatives has created conditions that demand a comprehensive Chinese response to address both the structural challenges and the strategic implications of their artificial island vulnerabilities. China's damage control efforts. Beijing's response has been swift but predictable, following established patterns of denial, while quietly launching the most extensive repair program in artificial island construction history. Chinese officials continue to maintain these installations serve primarily civilian purposes, with the PRC Ministry of Foreign Affairs reiterating in 2025 statements that the facilities focus on fisheries management, weather monitoring, and maritime rescue operations. This messaging strategy attempts to deflect international attention from the massive emergency construction projects now underway across multiple installations. Chinese media coverage systematically avoids discussing structural problems while highlighting successful aspects of artificial island operations. Official press releases emphasize scientific research achievements and improved navigation safety for regional shipping, describing ongoing construction activities as routine facility improvements rather than emergency repairs addressing fundamental structural failures. Recent Ministry of Resources and Information statements showcase Chinese deployment of advanced dredging equipment for what officials term enhancement projects, carefully avoiding any reference to foundation settlement or concrete deterioration issues. The scale of new construction projects launched during 2024 and 2025 reveals the true extent of structural challenges despite official denials. These efforts far exceed routine maintenance activities and involve complete reconstruction of major infrastructure components including runway sections, harbor facilities, and building foundations. The urgency and scope of these projects indicate China faces serious structural failures requiring immediate expensive solutions to maintain operational capability across its artificial island network. New seawall construction has begun at multiple locations, where existing shoreline protection proves inadequate against wave action and tidal forces. These seawalls extend far beyond original construction boundaries and feature reinforced concrete designs intended to withstand storm conditions that previous structures could not handle. The seawall projects require massive amounts of specialized marine concrete and steel reinforcement materials transported to remote locations at substantial cost, with construction crews working around the clock to complete critical sections before the next typhoon season. Foundation strengthening initiatives across multiple installations involve extensive excavation and concrete injection work designed to address ongoing settlement problems. These projects require specialized equipment including deep drilling rigs, concrete pumping systems, and underwater construction tools that must operate in challenging marine conditions. The foundation work extends below existing structures to reach stable load-bearing materials that can support artificial island infrastructure more effectively than original coral-based foundations. Runway reconstruction projects represent some of the most expensive emergency repairs undertaken on Chinese artificial islands. Complete runway sections require removal and replacement with new concrete designed to resist settlement and environmental degradation more effectively than original construction materials. The runway work involves precise grading and surface preparation that must meet military aviation safety standards while operating hundreds of miles from mainland construction support facilities. China has accelerated development of new marine construction technologies specifically designed for artificial island maintenance challenges. The deployment of what China describes as the world's largest suction dredger, 50% more powerful than previous generation equipment, demonstrates the scale of resources being committed to addressing ongoing structural problems. These vessels include precision sediment placement systems, underwater concrete pumping capabilities, and equipment for working in the restricted waters surrounding existing artificial island installations. Specialized engineering units have been deployed to artificial island locations with equipment and expertise specifically focused on marine construction challenges. These units include personnel trained in underwater concrete work, foundation stabilization techniques, and emergency repair procedures that can operate in harsh tropical marine environments. The engineering units maintain permanent stations on artificial islands to provide immediate response capabilities when structural problems develop, reflecting the unpredictable nature of foundation settlement and environmental damage. Construction timelines have been dramatically accelerated to address urgent structural problems before they compromise artificial island operational capabilities. Emergency repair protocols now prioritize immediate stabilization work over long-term solutions, reflecting the severity of structural challenges affecting multiple installations simultaneously. The accelerated schedules require premium payments for construction personnel and equipment, while accepting higher material costs associated with expedited procurement and transportation to remote marine locations. Chinese military doctrine has evolved to account for operational limitations created by artificial island structural problems. Military planners now recognize that runway settlement and harbor deterioration directly affect aircraft operations and naval vessel deployment capabilities. Strategic planning incorporates artificial island maintenance schedules that temporarily reduce defensive capabilities during major repair operations, forcing commanders to rely more heavily on mobile assets that do not depend on fixed infrastructure. The adaptation of military strategy includes greater emphasis on aircraft carrier operations, submarine capabilities, and mobile radar systems that provide strategic benefits without requiring permanent installation on vulnerable artificial platforms. This strategic shift reflects recognition that artificial islands may not provide the reliable military capabilities initially anticipated, leading to increased investment in Coast Guard and maritime militia assets that can operate independently of fixed installations. China's South China Sea strategy has been modified to work around infrastructure limitations while maintaining territorial claims and strategic presence. Operations planning accounts for periods when artificial island facilities operate at reduced capacity due to ongoing repairs or structural concerns. Emergency response protocols have been established to maintain minimal operational capability when structural problems compromise artificial island infrastructure, including procedures for rapid equipment relocation and backup logistics arrangements. Investment in marine construction research has increased substantially as China recognizes that maintaining artificial islands requires technological capabilities beyond those needed for initial construction. Research priorities include developing concrete formulations that resist saltwater corrosion more effectively, foundation techniques that provide better stability on coral substrates, and construction methods adapted to the logistical constraints of remote marine locations. These extensive damage control efforts represent China's most ambitious attempt to address fundamental engineering challenges that threaten the viability of its entire artificial island strategy. The success or failure of these emergency measures will determine not only the operational future of these installations, but also their broader strategic value in an increasingly contested region, where multiple scenarios for their long-term survival are now being seriously considered by military analysts worldwide. Future scenarios and strategic implications. Engineering experts analyzing current trends project three distinct scenarios for China's artificial island network over the next decade, each carrying profound implications for regional security and international relations. The first scenario involves successful stabilization through massive technological investment and engineering breakthroughs that address fundamental structural problems. The second scenario envisions partial abandonment, where China maintains only the most strategically valuable installations, while allowing others to deteriorate. The third scenario predicts complete structural failure across multiple installations due to accelerating environmental pressures and engineering limitations that prove impossible to overcome economically. The successful stabilization scenario requires China to develop revolutionary marine construction technologies that can overcome the fundamental challenges of building on coral reef foundations. This outcome would demand continuous investment exceeding current spending levels, with speculative estimates suggesting costs could reach $150 billion over the next decade based on the substantial amounts already spent and observed maintenance cost multipliers. Success would consolidate Chinese territorial control over disputed waters, while demonstrating that engineering determination can overcome natural environmental forces through sufficient financial commitment and technological innovation. Regional implications of successful Chinese stabilization would fundamentally alter South China Sea power dynamics. Other claimant nations would face permanent Chinese military installations capable of projecting force across previously contested waters. The Philippines, Vietnam, and Malaysia would need to accept Chinese dominance or invest heavily in countermeasures including advanced missile systems and strengthened alliances with external powers. International shipping companies would operate under permanent Chinese oversight of critical maritime trade routes, carrying trillions of dollars in annual commerce. The partial abandonment scenario appears increasingly probable as maintenance costs spiral beyond sustainable levels while structural problems compound across multiple installations. China might concentrate resources on maintaining Fiery Cross Reef and Reef while allowing smaller installations to deteriorate gradually. This selective approach would preserve core strategic capabilities while reducing financial burden and acknowledging engineering limitations that make universal success impossible. Partial abandonment would signal strategic retreat that could embolden other claimant nations to assert territorial rights over areas where Chinese installations fail. Vietnam and the Philippines might establish their own facilities on abandoned Chinese sites, creating new territorial disputes and potential military confrontations. The precedent of Chinese withdrawal could encourage other nations to challenge remaining Chinese installations through economic pressure and diplomatic isolation. Complete structural failure represents the most dramatic scenario, where multiple installations become operationally unusable due to runway collapse, harbor degradation, or building failures that cannot be repaired economically. Research suggests that low-lying artificial islands could be swallowed by sea level rise within decades, making this scenario increasingly plausible. This outcome would constitute one of the most expensive engineering disasters in modern history, potentially costing China over $50 billion in lost investments, while creating environmental hazards from concrete debris and contaminated materials entering marine ecosystems. The failure scenario would devastate Chinese international reputation and undermine confidence in China's global infrastructure projects, including the Belt and Road Initiative. Countries considering Chinese construction partnerships would question Beijing's engineering capabilities and project management competence. The diplomatic damage could persist for decades as China struggles to rebuild credibility in international development markets. Climate change acceleration threatens artificial island stability through multiple simultaneous environmental pressures that exceed original design parameters. Sea level rise rates have reached 4.2 millimeters annually in the South China Sea, creating permanent flooding conditions in areas that were originally constructed above high tide levels. Rising temperatures increase thermal expansion cycles that weaken concrete structures, while generating more intense tropical storms that subject artificial installations to unprecedented stress loads. Ocean acidification caused by increased atmospheric carbon dioxide levels accelerates chemical attack on concrete foundations and steel reinforcement materials. The combination of higher sea levels, stronger storms, and more aggressive chemical conditions creates environmental challenges that may exceed any reasonable engineering solution. Climate projections suggest these conditions will worsen throughout the 2030s, potentially making artificial island maintenance impossible regardless of financial investment. Advanced construction technologies offer potential solutions to some artificial island challenges, but fundamental engineering limitations may prove insurmountable. China has developed more powerful dredging vessels and specialized marine concrete formulations designed to resist saltwater intrusion and thermal stress. Underwater foundation injection techniques can potentially address settlement problems by strengthening load-bearing capacity beneath existing structures. However, the coral reef substrate underlying these artificial islands represents a geological condition that cannot be fundamentally altered through surface engineering techniques. The ongoing consolidation of dredged sediments continues regardless of surface reinforcement efforts, creating persistent settlement problems that require continuous expensive intervention. New technologies may slow degradation rates, but cannot eliminate the underlying geological instability that affects every artificially created island. International cooperation on maritime safety standards could provide frameworks for managing artificial island risks while reducing regional tensions. Proposed standards would establish construction requirements, environmental monitoring protocols, and abandonment procedures that apply to all nations engaged in land reclamation projects. These standards could address legitimate safety concerns about navigation hazards and environmental damage, while avoiding direct challenges to territorial claims. The development of international oversight mechanisms faces significant political obstacles in the South China Sea, where territorial disputes complicate any cooperative agreements. China maintains that existing installations serve legitimate civilian purposes and therefore should not be subject to international regulation. Other claimant nations worry that international standards might legitimize Chinese territorial claims by recognizing artificial islands as permanent territorial features. Artificial island outcomes will influence territorial dispute strategies in other contested regions, including the Arctic, Mediterranean, and Indian Ocean, where nations consider land reclamation projects to support territorial claims. Success of Chinese artificial islands could encourage similar projects by other nations seeking to establish facts on the ground in disputed waters. Failure would demonstrate the limitations of artificial construction as a territorial expansion strategy. The broader implications extend to China's global infrastructure reputation and soft power projection capabilities. Chinese companies market engineering expertise worldwide based partly on achievements in challenging construction environments, including the South China Sea. Structural failures would undermine confidence in Chinese construction capabilities and reduce demand for Chinese infrastructure services in international markets. The 2016 Permanent Court of Arbitration ruling established that artificial islands cannot generate exclusive economic zones, creating legal precedent that limits the territorial value of these installations regardless of their structural condition. This ruling means that even successfully maintained artificial islands cannot legally extend China's maritime boundaries under international law, reducing their strategic value compared to natural territorial features. The artificial island experience may influence future interpretations of the United Nations Convention on the Law of the Sea regarding artificial structures and territorial waters. Courts might require evidence of long-term structural viability before recognizing any territorial benefits from artificial construction. This legal framework could affect territorial disputes worldwide where nations consider artificial island construction. The outcome of China's artificial island experiment will determine whether massive engineering projects can successfully challenge established international maritime boundaries, or whether natural environmental forces ultimately prove stronger than human territorial ambitions. The mounting evidence suggests this unprecedented gamble may have pushed the boundaries of engineering possibility too far, with consequences that extend well beyond the South China Sea itself. China's artificial islands represent a historic miscalculation where territorial ambition exceeded engineering reality. The massive investment in coral reef construction has created installations that require constant expensive repairs while facing accelerating environmental pressures that may prove insurmountable. These crumbling structures could ultimately strengthen international maritime law rather than Chinese territorial claims, as their instability demonstrates that artificial constructions cannot establish permanent sovereignty over disputed waters. The structural failures visible across multiple installations provide concrete evidence that engineering cannot always overcome natural forces, regardless of financial commitment. The 2016 Permanent Court of Arbitration ruling already established that artificial islands cannot generate territorial waters, and mounting evidence of structural deterioration reinforces this legal precedent. These islands risk becoming monuments to costly hubris rather than lasting strategic assets. Engineering limits may force China to rethink its island strategy or risk permanent strategic liabilities.